Hello everyone, this is Experiment 3 Circuits by Kiana White. First we're going to go over the purpose, the fundamental principles, the results, and the discussion. So the purpose of this experiment. So the purpose is to predict the behaviors of the circuits containing resistors in parallel and in series, then to use multimeters to measure the actual values of the conventional current and potential differences in the currents, and also to examine the behavior of ohmic resistors and capacitors. 2. The fundamental principles of this experiment. One of the fundamental principles is Ohm's law, which is voltage is equal to current times resistance. Capacitance, which is charge divided by voltage. The node rule, which is current in equals current out. So if there is a node, then the amount of current going in will equal the amount of current leaving. And then the loop rule, which that should say delta V, which is the sum of all the voltages is equal to 0. So if there were 6 voltages, so V1, V2, V3, V4, V5, V6, they will all equal 0 when summed together. So the results of this experiment. So first, the procedure was to use the circuit construction kit AC to create a circuit. There were 2 circuits created. There was the one pictured above, and there was another one that used capacitors. So for part 1, there were 2 1.5 voltage batteries, 2 resistors, one of 47 ohms and the other of 100 ohms, and there were 2 ammeters. One of the questions that was asked was to predict the current, and the predicted current using Ohm's law was 0.0204 amps, and the actual current that was read by the ammeters in the circuit construction kit was 0.02. And when the ammeters were reversed, there was the current was negative 0.02 amps. Part 2 was to do this in an open circuit. So the predicted current was a 3-volt battery, which is the black battery in the construction kit, and the 0-volt battery was the red battery. The predicted was 3, and the actual current was also 3 volts. The voltmeter and this was because the voltmeter has limitless resistance. Oops, I think I skipped too many. And okay, no, I'm on the right side. Sorry. So part 3 was using the ammeters in parallel, and in parallel, the current increases from 0.2 to 0.6, and this is due to Ohm's law. And then lastly, the Ohm's law's calculations at the end. The R47, so the resistor at 47 ohm, the resistors at 100 ohms, the resistance wire, and the resistance ammeter. These are the calculations. So the resistance was 48, 103, 0 ohms, and the ammeter was also 0 ohms. So discussion. What if you were doing this experiment in real life and used an actual ammeter instead of an ideal? What is different about the real, and how would it affect the circuits when hooked up? So the real life results would not be as accurate because ammeters have resistance. Therefore, the numbers would not be the same, the calculated voltages. And then if you were doing this experiment in real life and used a real battery to charge a capacitor with no resistor in the current, how quickly would our ideal model predict the capacitor to reach full charge? would this prediction happen in real life? The capacitor would be charged immediately if there were no resistors, but all components of a battery or a circuit have resistors, so it would take time. And then here is just a graph of the capacitance charges from part 4 of the experiment. It was part 2, but part 4 for mine. Thank you so much.